And this result I'm putting for discussion. So this is the abstract structure for a pure mathematician. So in order to conceptualize some ideas or thoughts, whatever he is getting, to present his view on new topics. That is the second one. Coming to the third one, it is abstract pattern. So abstract patterns are about exploring visual languages or shapes. So one of the disciplines of mathematics, I'll explain that one. So is to analyze the shapes. You can have what is called as the codes and ciphers. Alan Turing is a scientist who reduced this World War to almost, I think his time, he reduced the war to almost half. If Alan Turing was not there, the World War would have extended furthermore, Second World War at least. But because of this person, the World War was reduced to, the timing of the World War was reduced to half. So that we will again discuss in the coming discussion of presentation. So the abstract patterns, maybe some will be working on the codes and ciphers. So abstract patterns, exploring the visual languages of shapes, the colors, the forms, to create something new and engaging, whatever it's piece of art or design element or a software design solution driven by the intellectual curiosity. So all the research pattern may not be unique. It may not be the casual traditional approaches. Some are unique. So all of these abstract patterns, the abstractation, what we are calling that, or abstraction, what we are calling. So abstract conception, structuralization of abstract, and abstract.
Okay.
And it up. Okay. So this intellectual curiosity is to try the intellectual curiosity. So you're going to work on the abstract patterns. The goal of the pure mathematics or the real realm of the abstraction is to expand the horizon of mathematical thought process. So to expand the horizons of mathematical thoughts, new ideas, new proofs, new theories, and new implementations, new proofs, new reasoning, new methods, new discussions, and so on. Right? The goal of pure mathematics, in short, can be to expand the horizons of mathematical thought, because no engineering or scientific problem cannot be proved without mathematical thought. Right? So that mathematical thought process, based on different abstracted concepts, abstract structures, and patterns, and driven by the intellectual curiosity. So how the third pillar, which is computation, is able to address some of the problems of the pure mathematics, the real realm of abstraction. We can look into it. And this is first part of pure mathematics, the realm of abstraction. Now, coming to this pure abstraction, pure mathematics, generally the research areas, what we come across in the pure mathematics is the algebra and number theory, the study of abstract structures, groups and rings, and their properties of integers. One of the research area, what we have in pure mathematics happens to be algebra and number theory. The second one happens to be the geometry and topology, the study of shape, space, and properties preserved under deformation. Right? Second key research area what we have. And third one happens to be the analysis, a rigorous mathematics of change, providing foundations for calculus. Calculus comes under it steps in at the third point of analysis, because no analysis is there without calculus, right? So analysis, the calculus, comes in as a third point or third key area of research for a pure mathematician. And fourth happens to be the logic and foundation, investigating very foundations, the limits of mathematical reasoning. So logic and foundation, the fourth key research area, so where a pure mathematician can concentrate. So if at all you you're researching it is fine. But if at all you're able to yet to start the research, maybe you can choose either a pure mathematics side or applied mathematics side. If you're searching pure mathematics, the areas may be algebra, number theory, geometry, topology, analysis, logic, and commerce. These are the 4 different areas. Maybe some more are there. But from the engineering perspective of mathematics, because I'm an electrical engineer, so in my engineering, from the concept of engineering, so how research in mathematics generally will be. In that thought process, I prepared these 4 key areas, what I have got. Coming to the applied mathematics, the modeling the fabric of reality. So reality is there, real-based solutions are there, the fabric of reality, how it is. So the applied mathematics deals with modeling. Modeling is mathematical realization of a real system or a real problem or a day-to-day life problem or a real-time solution and so on and so on. So you can see pure mathematics, a realm of abstraction. Pure mathematics is totally a realm or a world of abstraction, whereas applied mathematics is a fabric of reality. So these are the 2 ideologies what we have. The core objective of this applied mathematics is to translate the complex real-world issues into the language of mathematics to find the concrete solution and generate insights. So mainly applied mathematics outcome is what? To find the concrete solutions and to generate the insights for the real-world issues and real-world problems. So if the pure mathematics is trying to communicate the realm of abstraction, the applied mathematics will try to convey the language of mathematics in the form of providing concrete solutions and generating the insights. So these are the methodologies what we have in applied mathematics. So key research areas of this is mathematical, physics, and engineering problems. Most of the engineering problems come under the category of applied mathematics. So in this, they model the natural phenomenon and design the systems using mostly the differential equations, the ordinary differential equations, partial differential equations, and so on and so on and so on. Right? So rather than going for a higher order system, break that higher order system into single order system, higher order system to what do you call it as first order system or a second order system, and thereby you come and make an analysis. So mathematical, physics, and engineering is one key research area for applied mathematics. The second area for applications of mathematics is the mathematical biology and medicine. Simulate the disease spread. The disease is spreading, at what rate it is spreading, the rate of spread. Analyzing the gene networks, understanding biological systems. So this is the second part of mathematics, the applied mathematics, where its applications are found. So if you extensively use it, if you master this methodology, you'll be one of the very, what you call it as, very expensive person. Your demand will be so much. Right? So I'll reduce my words because time is running. Third is the financial mathematics. The applied mathematics will find its application in financial mathematics using the stochastic. So involving the chance of probability stochastic models. Optimization is one key research area. So minimization and maximization, 2 different problems we have. Optimization for the risk management and investment strategies. So this is a third area where your applied mathematics can be felt. Its presence can be felt. And fourth is the most recent advancements, the data science and machine learning. And most of the times, even though it is the separate branch is opened under computer science, data science, machine learning, CSE, AIML, artificial intelligence, data science, artificial intelligence, machine learning. Even though they claim that data science and machine learning is theirs, but purely it is mathematical learning. The mathematics should claim the people of mathematics or the branch of mathematics should claim the data science own. It has to own the data science and machine learning methods. So it uses statistics. The second one is the probability. Third one is the linear algebra to build predictive models for the data. Means it is purely mathematical approach, but analyzing the data and making the machine to learn a particular approach. Right? So these are the key areas of research in case of the applied mathematics, which in short we can call it as the modeling the fabric of reality. Reality fabric is modeled by using applied mathematics structures. So the computational math. So this is the third pillar to bridge between the worlds of pure and applied mathematics. Third pillar of science, which we are calling it as what? This third pillar of science, which is called as the computation. Computation comes into play to bridge the gap between the two worlds of pure and applied mathematics. Alongside theory and experimentation, computation has emerged as a revolutionary force in what? Research. We have lost something and we are searching it, we're not able to find, we are researching it and so on. So the computation has become what? It has become a revolutionary force in research. Searching again and again and again. So the revolutionary force is a computation, which is a third pillar of science we generally call. And this computation is very much required. And for computation, you need the software to compute a particular methodology, a particular task. So we have introduced the third pillar of computation in mathematics. Now, when we look into this one, the role of computation, if you look, it allows the pure mathematics, in the role of computation with respect to pure mathematics and the role of computation with respect to applied mathematics. So what they are trying to do is, the role of computations allows pure mathematicians to explore abstract topics and discover the patterns, leading to new conjectures. So what are these conjectures? Which are called as the guesses or estimations. Okay. So the computation supports the mathematicians to explore the abstract objects, discover the patterns, leading to new junctions of ideas in the form of guesses or estimations. So the computation provides the pure mathematician with guesses and estimations, the ideology, theory, and so on. Right? So what the computation empowers the applied mathematicians is, the role of computation empowers the applied mathematicians to simulate what type of systems? Complex systems like climate variations and so on and so on, that I will discuss in the coming slides, that are impossible to solve by hand. So with the normal hand procedures of solutions, for all those tasks which are impossible to be solved by the hand, the computation, which is a third pillar of the science or mathematics, it will try to provide, it empowers the applied mathematics to simulate complex systems which is impossible to be solved by the hand. So uniform, sorry. So it empowers mathematicians, applied mathematicians to simulate complex systems, climate variations, climate change that are impossible to be solved by hand. And it is a unifying force. It is also called as the unifying force. So computation connects the abstract language of the pure mathematicians and with the concrete problems of applied mathematics. So enabling a new level of discovery. So if a pure mathematician and applied mathematician meet, there is a new level of discovery. New discoveries will be important. So it is not, it can't predict. So they can do wonders when the pure mathematics combines with the applied mathematics. The unifying force, the force which unifies, which bridges the gap between pure mathematics and applied mathematics. The unifying force happens to be what? Computation. So computation is very, very, very key important role. It plays very key important role. And it is very key important parameter in ideation, communication, interaction, and application, validation. So all of these approaches can be solved by computation, which acts as a bridge between the two realms or worlds of pure and applied. So you can, every mathematician can proudly talk about this. This is a phenomenon of enigma, the catalyst for a mathematical revolution. So this person is Alan Turing. Alan Turing was an English mathematician, computer scientist, logician, cryptanalyst, philosopher, and theoretical biologist. So he invented a machine called as the Enigma machine, which is called as the Bombay, B-Y-M-B, Bombay. So he tried to, because the Second World War is going on at a peak, and the German forces and the other Allied forces, they're on war. So this person, Alan Turing, was a English mathematician. He belongs to the Great Britain. So, because if a war is to be strategically won, at that time, now the Air Force came into existence. But in those days, Air Force role is less. But the ship fleet, we can call the ship role, warships role is very important. So Germans used to send message over the radio to locations that strategically the ship has to be moved from this location to this location. So that we sent through radio signal. So radio signal were intercepted by the British system, but they don't know how to decode it. So if they decode it, they know the locations, and when exact locations are known, they can be bombed and the ships can be collapsed. And if ship is collapsed, war is over. That was the strategy in those days. Now the strategy changed. So this Turing has invented a machine called as the Alan Turing machine, which is called as the Bombay. You can see it. Bombay was a specialized logic machine to find the contradictions. So he tried to. He is working under a wing called as Codes and Ciphers. Codes and Ciphers. So the English army had a special thing called as Codes and Ciphers. So they'll take the codes, the code languages or scripts of unknown languages can be studied and decoded. So that was a task, and Alan Turing was he was a mathematician who was appointed to decode the codes of the German. So later on, he invented a machine. This is the machine he invented, the Enigma machine. And finally, he decoded. And because of that, the German allies were, they lost the war. The English people, they won the war, right? Because of this particular person, a great mathematician. So there was a controversy regarding his life also. That is not our issue. So the mathematical people happen to be the proud people. Now, the recent methodologies, whatever are going on, maybe some of you have already seen this. So the statistics was there. The computer science people were there. The computer science people tried to take the help of statistics. So we can see here, they asked, we can work together. And because of this working, so please teach me the statistics. So likewise, the computer people came and asked the giant, which is the elephant-like statistics. And finally, what happened? It became what is called as, a dinosaur. So combination of statistics and computers became a dinosaur and studied under a new heading called as the data scientist. Okay. So mathematics is the key role, is the key basic for either data analysis or data science or either machine language. So without mathematics, no other part is there. So generally, they all will say English is the language of communication throughout the world. But to be frank, to the core, mathematics is the communication of the language, or the communication of the world, or language of the world. Right? So So with this, I think it should not take much time on this one. So this catalyst of mathematical revolution, the enigma, forged new mathematical fields. The applied abstract algebra and combinatorics. Combinatorics or combinatorics is a next type of research area which sprung up. Next is industrialized statistic interference or inference or inference. The third one is the birth of machine computation. So this person was the father of computation system. And all of these, father of computation system is a mathematician. That is greatness of a mathematician. In mathematics, people has to own this particular person, Alan Matheson Turing. Right. With this short brief, I think I have to cut here. Move to the next story. So this is the overview of mathematical research disciplines and their computational needs. So before what I was talking is this slide. So the first one is the research disciplines. In this table mainly is divided into subcategories of research discipline, the core objectives of a particular research discipline, and primary computational needs of a research discipline. And fourth column is the representative software categories which aid the research discipline. Right? So these are the different parameters which were taken to distribute the data available with respect to research disciplines and their computational needs. It was categorized. I have kept this in 4 different categories. So because I have used this in my research in one form or the other, so that's why I have. I think I know from that known part of mathematics. I segregated it into one is analysis, partial differential equations to analyze the dynamical systems. Second research discipline is your algebra, geometry, and group theory. And third one is the geometry and topology. So I have used this geometry and topology to derive different topological aspects. These are the different topologies. So by using the topology and graph theory, I have developed some important theories and methodologies for analyzing converter systems. And fourth one is the number theory. Fifth one is the discrete mathematics. So I use this discrete mathematics for building up discrete controller designs. I mean, multi-input, multi-output controller design, which uses the conditional number and singular value decompositions and so on that I'll try to explain. And sixth is the logic and foundation, sorry. And seventh happens to be the probability, statistics, and financial maths, one area. And eighth happens to be the applied computational mathematics. So we are going to discuss this table one, which is an overview of major mathematical research disciplines and their computational needs. Is segregated into 4 columns: research discipline, core objective, primary computational needs, and representative software category. It also gives you a brief idea of 8 different research disciplines in mathematical research: the analysis of partial dynamic systems, algebra, geometry and topology, number theory, discrete mathematics, combinatorics, logic and foundation, probability, statistics, and so on. Right? So we will look one after the other. So the analysis part, if you look, the partial differential equations to analyze the dynamic systems, model and simulate continuous physical and abstract systems that evolve in space and time. So these are the core objectives of analysis of the dynamic systems. So generally, high performance numerical solvers such as ordinary differential equations. ODE means ordinary differential equations, PDE is partial differential equations, in matrix computations, data visualization, 3D and 2D plotting, animations, and parallel computing. So parallel computing is one more key research area where extensive use of mathematics is done. So this demands this particular research discipline of dynamic system analysis, which has the objectives and computational needs. So it demands a software which is capable of giving or providing numerical computational environments. So that we will discuss numerical computing environments. So that is a representative category of the software which is needed. A software which is used to analyze the dynamic systems has to provide you the numerical computing environments. That is first category. Coming to the second category in the research discipline is algebra, the algebraic geometry and graph theory. So in this, we're going to study the abstract structures, symmetries, the odd, even, and so on, the partial symmetries and so on, and geometric objects defined by the polynomial equations. So generally, algebra consists of polynomial equations. So each and every abstract structure, symmetries, and objects and the problems were analyzed in the form of polynomial equations. And this needs primary computation need of algebraic geometric theory-based research discipline. The common needs are symbolic manipulations, polynomial architecture, polynomial arithmetics, discrete algebra solvers, arbitrary precision arithmetics. These are the computational needs of algebraic systems or algebraic discipline requirements. And what is needed? The software which is supposed to address the problems of algebraic research discipline, they need computer algebra systems. We used to call it as CAS in short. It's called as CAS. Computer algebra based systems is the environment or representative software category needed to analyze the second type of research discipline, algebra. Coming to third, the geometry and topology, they have to investigate the properties of shape, space, and invariance under continuous deformations. Right? So these type of core objective need the computational needs of the geometry and topology, which deals with the shape, space, invariance, and so on, continuous deformations. They need the needs of such a discipline of geometry and topology is symbolic derivation of geometric properties, numerical solutions of flows, visualization of complex surfaces, and manifolds, algebraic computations. So these are the needs, primary needs of a computational software when you are working on what is called as the geometry and topology. And the environment, so the software category, what it has to provide is the software, if you're using some software to simulate geometry and topology, so that software, what it has to provide is CAS, what we have discussed about computer, arithmetic algebra, has to provide numerical computation environments, has to provide. So these are the two requirements of geometry and topology discipline, and the software has to provide it. And fourth one is the number theory. What are the objectives of the number theory? Properties of integers, prime numbers, arithmetic structures. And these all need high speed. I'll go a bit fast because time is running. So high speed integer factorization, primality testing, modular arithmetic, computations with elliptical curves, symbolic numbers, theoretic calculations. So these are the requirements of number theory to deal with the properties of integers, prime numbers, and arithmetic structures. And the software which is supposed to be employed for this type of requirement has to provide you specialized computer algebra systems and numerical computing environments. Right? So these are the requirements of number theory. It is research discipline of number theory in mathematics. Next, coming to the most important discipline, which we call it as the discrete mathematics. Maybe as a mathematician, you might not be knowing the importance of discrete mathematics and combinatorics, but discrete mathematics is extensively used. It is very, very, very essential in digital electronic and digital designs. Discrete mathematics, that transform based discrete systems. So breaking the continuous system into discrete system, and discrete system is coded, and coded system is digitized. So in analog to digital conversions and digital to analog conversions, the discrete mathematics is extensively used, and the region of convergence issues are to be addressed. And convergence is the main problem in discrete mathematics, the convergence related issues, and combinatorics, so which is combination of different graph and so on. So this discrete mathematics and combinatorics as to the core objectives of this is to analyze the finite or countable structures such as graphs, networks, and configurations. Right. So these objectives, what they demand, the computational needs of such objectives, what they demand is the graph algorithms, the combinatorial optimization, enumeration, network analysis, visualization, and integer programming. So these are the demands, primary conceptual demands of discrete mathematics with objectives of countable structures, graph networks, of configurations. And the software which you are going to employ to simulate these type of needs has to have numerical computing environments and specialized libraries. This we will look into it. So these are the demands, and a software which is employed for discrete mathematical combinatorics has to provide the computing environment, numerical computing environment, and specialized libraries to dedicated libraries to address this type of issues. Right? So that is fifth one. And coming to sixth is the logic and foundation. So what are the objectives of logic and foundation? Is to formalize mathematical reasoning and verify the correctness of the proofs and algorithms. So this is the foundation for logic, and this is the base for the logic and foundation. Formalize the mathematical reasoning, verify the correctness of the proofs, and develop the algorithms to cater the requirements of mathematical reasoning and verification proofs. Right. So these objectives of logic and foundation need a computation tool which is capable of giving you the formal proof checking, automated and interactive theorem proving software. Proof has to be provided, whether it is valid or not, can it be realized in the real world or not. All of that has to be checked in this one. So the software which is used for logic and foundation has to provide a formal proof checking and automate and interactive theorem proving, model checking, logical framework, and implementation. So this needs of the logic and foundation. A software, if it is supposed to cater, if you are supposed to select a software for logic and foundation with this type of needs, so such software has to provide you what? It has to provide you an interactive theorem provers. So you have to select a software which is capable of providing you interactive theorem provers. Right? So with the advent of AI, all of this can be got in the tips. Much more developments had done. So this is about your sixth research discipline. There is the logic foundation. And coming to the seventh, what is that one? The probability, statistic, and financial mathematics. As you know, so model uncertainty will be there. Analyze the data. The worst case analysis you can call Monte Carlo analysis. Generally, the Monte Carlo analysis, you generally call it as the worst case analysis. So how model uncertainty is there. So how you're going to analyze the data. You have to quantify the risk. Worst case analysis generally needs quantification of this in complex systems. So such type of objectives are there in probability, statistics, and financial mathematics. So what are the primary computational needs in such probability statistic systems is statistical modeling, the regression and classification. Right? So basics, what we have, Monte Carlo simulation, time series analysis, data wrangling and manipulation, and advanced data visualization. So these are the computational needs of probability statistics and financial mathematics. And the simulation software, when you are going to select it, it has to provide statistical analysis in the form of charts and comparisons and so on and so on, platforms, numerical computing environments. Right? So these are the requirements of probability, statistics, and financial mathematics. And coming to the last division, what I have for you today in the research discipline is the applied computational mathematics. So develop, analyze, implement algorithms for solving mathematical problems numerically. So analysis and implementation, algorithm development to provide a solution for the mathematical problems what we are going to formulate. And this has computational need of algorithm development environment, numerical linear algebra libraries, optimizer solvers, and scientific computation frameworks, performance. And you have a performance, that performance has to be a profile. So when the profile is made, we can check what are the positive areas, negative areas, advantage, disadvantage, SWOT analysis, strength, weakness. After that, you have what are the threats we have and opportunities what we have. So that SWOT analysis can be performed. Right? So applied computational mathematics has to give you proper profiling of the performance. And the software which you're going to employ for applied computation mathematics has to give you numerical computation environments, computer algebra systems. So these are the two requirements. So numerical computation environment and computer algebra class is there in 1 and 2 and 3 and 4 and 5, okay, and 6. Almost all. So they demand numerical computation environments and computer algebra systems. Right? So these are the overview of the major mathematical research disciplines and all the computational needs of those individual disciplines are being tabulated in this table, and it is present. Okay. Hope I'm clear. Any doubts so far? Any doubts? Yes, Sunita? Yes, Sunita ma'am? Any doubts? Someone raised the hand. Okay, we'll move ahead. So once this is the presentation is over, you can go for it. Right. So we have seen in this one the overview of major mathematical research disciplines and computational needs. So we will see in the next slide what are the softwares we have and how they are able to represent the problems which were addressed in this. They were used to represent the computational needs of different research disciplines and how they are unique in their own style. We will look. So we'll look into the softwares, the type of softwares which we generally use. I try to list, I think 5 softwares I have listed, and I'm going to the next slide. So these are the features and philosophy comparison of major mathematical softwares. So I'm taking for the comparison, the first one is MATLAB, second one is the Python, third one is the R, fourth one is Maple, and fifth one is Mathematica. Right? So these are the 5 different software tools, mathematical softwares, which is used, which are the basics for comparison, keeping in view of the above requirements of research disciplines. Right? So here the criterion, how I have categorized, how I have made this table is, first one is the criterion. In that criterion, you have the primary paradigm. Paradigm is some sort of show or model. Paradigm is nothing but a model. Primary model, we can say ecosystem model, cost model, target or watchers, key strengths of these softwares, key strengths and the key weaknesses, and support model. What any problem is how support is provided. Okay, so we'll look into one another. So altogether you have one is primary paradigm, the primary model. Second is the ecosystem model. Third is the cost model. Fourth is the target watchers. Fifth, key strengths. Six, key weaknesses. And seven, support model. So with these seven criterions of models, strength, weaknesses, and support, we will analyze the five softwares which we generally use extensively in mathematics: the MATLAB, Python, R, MATLAB, and Malla. So coming to one and one, going on head one and one. The primary model of mathematics is MATLAB. Sorry, primary model of MATLAB. MATLAB provides what? Numerical computation environment, hybrid with strong computer algebra system. It can provide computations to the very great extent, higher order systems, everything you can solve, right? So MATLAB, and the ecosystem of MATLAB is vertically integrated commercial. So there are two different integrations you can call. When you have, generally we call it as the x-axis and y-axis. So x-axis is the number of variables, what we have. And y-axis happens to be the specializations. So if you have vertical regions more, means what? If it is a vertical, what I mean to say here, vertically integrated commercial, means what? It has a limited number of variables or regions where it has mounted. So if I say algebra is taken as one variable. It has a peak, means vertical mount, means extensive vertical analysis or extensive analysis of high degree can be provided. So when your x-axis is less and y-axis is more, then it will provide you what? It will provide you with good analysis. And similarly, the next type of analysis, the next type of methodology is what? X is less. Sorry, we have discussed X is less and Y is more. Analysis part is. The second one is X is more. When the number of variables range, what you can perform or what you can select is, if it is more, what will be the y-axis? It will be less. Right? So vertical, if x-axis is more, if you have more number of topics, the software can simulate, the accuracy or the analysis part reduces. So if you have less number of variables to be discussed, and what happens? Each variable, like algebra, numerical computation, the depth, vertical mount will be high. So here, what I mean to say is vertical integrated commercial means it is highly commercial system. And it is licensed, cost is very high. So tired for mathematics students and all with a licensed software. And target watchers are MATLAB is extensively used in engineering, scientific methodologies and applied mathematics. So the applied mathematicians tool is MATLAB. So even it also aids the pure mathematicians also that we will see. The key strengths of MATLAB happen to be integrated workflow, validated toolboxes. There is an extensive part of MATLAB which is called as simulation thing, deployment. Documentation is very, very, very strong in case of MATLAB as well as Mathematica. Mathematica also provides wonderful documentation. So these two have a very strong documentations with respect to strength. So weaknesses of this, the main weakness is its cost. So one user of MATLAB, generally it will cost with the minimal toolboxes and all, it costs around 45 to 50,000 with minimal toolboxes. As you add more and more toolboxes, it goes to lakhs, 20 lakhs, 30 lakhs, 40 lakhs, 50 lakhs. Likewise, the amount will mount. Right? So it is highly expensive. Weaknesses are highly commercial license cost, closed source, less flexible for general program. So if you want to program this one, the programming chances, because it has to understand the code. So with the limited coding methodologies, what it has. So the flexibility with the general programming, less flexibility with general program, less flexibility with general program. That is the main two drawbacks. But whereas the other one, Python, whatever is there, steeper learning curve, scientific stack, inconsistent documentation, potential package conflict, but it provides you a good flexible programming environment. Right? And support and model, professionals are there. Centralized technical support is there. The support system of MATLAB is one of the strongest and the best supporting system what we have. Right? So this is about the MATLAB software. Is that good if I go with this, or shall I go directly with the MATLAB? Because I think you'll not find these type of comparisons, very less you can find. Shall I go with this? Because time is running, that is what I'm worrying about. Shall I go ahead?
Yes, sir. Yes, sir. Yes, sir.
Is that okay for you?
Yes, sir.
Yeah, thank you. Thank you so much for your feedback. So coming to the Python, which I call as Skype stack. So general purpose language and scientific libraries are there. Horizontal integrated open source. Horizontal means more number of topics you can simulate and you can have. It is a vertical integrated. MATLAB is vertically integrated system with limited topics but high y-axis. And Python is horizontal integrated with more number of topics. The vertical, that is specialization in each topic maybe. Yes, it is an open source. You need not keep any cost, freely available. That's why most of the students and faculty and research now, they are going through the open source ecosystem, that is Python, which is free and easily accessible. If you want to work on MATLAB, you have to put some cost on it. But Python, it is very no cost. You can call it as an open source. So cost model, free and open source, we can call it as FOSS. And target watchers are programmers, data scientists, and researchers. And key strengths are flexibility, vast library ecosystem, general purpose capabilities, and large community. Because it is free, people who use free things will be more. So large community is available at a key strength for Python. And coming to the weaknesses, a steeper learning curve for scientific stack. Steeper curve is there. I'll explain this. Inconsistent documentation. This is one of the drawback what you have. Because each can formulate, it is an open source, and each can formulate their own way of styling the approach. So the documentation is inconsistent with respect to Python, and potential package conflicts are there. On Python, some different concepts are there. The different softwares are there, which offers different sort of requirements. Anaconda and so on and so on. Different softwares are there. So support model is decentralized community support. It is not centralized. The support system is not present in a single company or single place. It is decentralized. So when decentralized community support is there, you don't know from where the help comes and how much time it will take to give that help also. Not. And decentralized means from different parts. One software can be segregated into different parts. And that each and every part can be addressed by particular session. One, if I say algebra session is there with India, so the applied session may be with China or some other country also, or in the same country, different locations may also be there. Decentralization of community support is there. Python. Coming to R, it is the statistical computing environment, very useful for statistic computation. Horizontal integrated open source system, free and open source. Statisticians and the data scientists and academics are the target watchers. Unparalleled statistic depth, excellent statistic depth is there. Plots to visualization, graphic plots to visualization, tidy workflow, all these are the key strengths. And slow for non-statistical computations. Right? So as the horizontal integration is so what happens? Slow for non-statistic computation. So steeper learning curves, less general purpose. So these are the drawbacks. And it is a decentralized community support. So mailing list, stack overflows, and so on. Okay. Is about R. Maple. Maple is nothing but a tree, orange color leaf tree. But it stands apart. It stands unique in its features. So Maple is a computer algebra system hybrid with strong numerical computation environment, NC, numerical computation environment. Vertically integrated, and it is commercial. It is vertically integrated and it is commercial. Means the number of applications are less, but vertical amount is high. So specialized techniques, you can use the Maple. Licensed hired for academics and students. Cost discount will be provided. Pure applied mathematicians and the educators are the target watchers. And the strength of this Maple is powerful symbolic engine, intuitive mathematical notation, educational tools. And key weaknesses is high license cost again is a problem because of the commercial software, less focused on large scale numerical simulation because it is vertical mounted. So it will not provide you many features, right? Professional, centralized technical support, Maple software is there. You can get a very good support in case of any model support is. Coming to the last one of the contemporary rivals of MATLAB is Mathematica. So computer algebra system is hybrid with strong numerical computation environment. Again, it is vertically integrated like MATLAB, and again, it is commercial. You have to purchase it. License will be provided for academicians and students with discount. Pure and applied mathematicians research. Right. Applied pure and mathematicians, research and researchers. So pure and applied mathematicians and researchers are the target watchers in case of Mathematica. And it provides premier symbolic engine, notebook inference, Wolfram is the language integration. What do you have? High license cost. Any problem? I think the organizers to please mute all the audience, please. Okay, high license cost, proprietary language, steep learning curve, professional centralized technical support from. So, support model is there. Professional centralized technical support. So these are the comparisons. Madam, can you please mute this person? Creating a lot of disturbance. Mr. Venkat Borra? Venkat Bora. Thank you. So with this comparison of mathematical environments, we will move on to the MATLAB, a primer. This was introduction to our course today. So MATLAB is a unifying platform for research. And MATLAB is derived, expanded to Matrix Laboratory. It's a prime example of a tool integrates the entire research workflow. For pure mathematicians, it performs, as we have said, two realms of mathematicians. So what MATLAB can provide. If that was not discussed in the earlier slide, maybe this will be discussed here. For pure mathematicians, they can use the MATLAB. The symbolic dedicated toolbox is there, which is called as the symbolic toolbox. And this symbolic toolbox, for a pure mathematician, it performs, MATLAB performs exact, analytic, and mathematical requirement solutions, and so on and so on. Solves equations symbolically, simplifies the expression, and assists theoretical exploration.
Sir, slide is not visible, sir. Sir.
Slide is not visible?
Yes, sir.
From when it is not visible?
Just few minutes.
Shall I repeat the last one?
Yes, sir.
Yeah. Now is it visible?
Yes, sir. Yes, sir.
What about the previous slide? Shall I explain this one once again? It is a comparison, ma'am. Later on, I can give it. You can just watch through it. And then you can interrupt me and ask. There is no problem at all. No hesitations, please. Okay, we'll go. So, pure mathematicians, MATLAB is useful to perform the exact and analytic mathematics. It solves the equation symbolically, simplifies the expressions, and assists in theoretical explorations. So the pure mathematician is assisted by MATLAB to perform all these exact and analytical mathematical approaches. Right. So to the applied mathematician, the MATLAB is useful for numerical solvers. So you have the ODE methods of ordinary differential equation, government price, partial differential equations. So you have variable step, continuous step. Because of solvers, different step approaches are there to arrive at the final solution. Methods are there. So I think 2 hours is not sufficient time to thoroughly discuss all this. It is some other time, if time permits, we will meet again. If at all, if you are interested, we can have one more session some other time. 2 hours is a very short time to explain about any subject. So for applied mathematicians, numerical solvers provides best solvers at ODE, ordinary differential equation 45, partial differential equation methods to simulate the complex models based on differential equations. The MATLAB provides support to applied mathematicians. It offers toolbox for optimization. Dedicated optimization toolbox is there, dedicated statistic toolbox is there, machine learning toolbox is there, biological toolbox is there, financial computation toolbox is there, and so on. So it offers a lot of flexibility to applied mathematician rather than pure mathematician. So for everyone, it will try to provide for either a pure or applied or any other persons. It provides visualizations, graphs, and prototype. These are the 2 important solutions that MATLAB provides. It turns abstract data into intuitive plots. So I can show the plots, how they look like. So is it visible?
Yes, sir.
Yes. Oh, okay. It's fine. So it will try to, I have plotted, I have got the equations. These are the equations of voltage gains. And I have plotted with 2 variables of duty ratios D1 and D2, the output voltage is plotted. So plotted between V0, D1 and D2. So it gives me an insight with D1 varying between this range and D2 varying between this range, what will be the output range I'm going to get. So when you have a mathematical equation and you have the variables, so by varying the variables, what will be the outcome and how the outcome is going on. So you can plot. So all these are MATLAB plots. So it will try to give you the maximum minimum values and how the variations of different is going on. Not only that, it will give you key insights into the variables when they're plotted against one another. Right? So likewise, you can have different sort of intuitive analysis you can have, right? So it will give you key insights into the system, and it offers you the flexibility to make a comparison, right? So converging the frontiers and future trends. ఎవరో కొంచెం మ్యూట్ చేయండి ప్లీజ్ వెంకట బొర్రా ఆయన కనీసం కొన్ని ఫోన్ చేసిన చెప్పండి. Okay, thank you. The converging frontiers and future trends. So the lines between pure applied and computational maths are blurring. Blurring means fading away, leading to exciting new frontiers. The independent phase. The theory provides the language. Always the theory provides the language. And problem provides the motivation. And computation provides the power to analyze. The theory provides the language, problem provides the motivation, and computation provides the power to analyze, to know the insights. So the interdependent phase. So this is essential for either pure mathematician or applied mathematician or whatever the researcher, whoever is that. So these 3 are required. So theory to language, problem to motivation, computation to power. Right? So future trends of these softwares. Is AI-driven mathematics. So all the traditional mathematics is going to disappear at one day or the other. So now what is going to happen is AI-driven mathematics is going to come. So using the machine learning, so every mathematician also has to learn the AI. artificial intelligence, right? So one or the other form should get trained. It makes the work very easy. If you are able to do a 10-day work, you can do it in half an hour or that with AI. So AI-driven mathematics is the future which is about to come. So I request all of you to equip yourself with AI-driven methodology and raise up interdisciplinary fields. If you're confining yourself only to mathematics, it's not at all acceptable. You have to work with engineers, you have to work with data scientists, you have to work with biology people, financial people, hybrid mathematics, computational skills are very much required. So raise of interdisciplinary fields is one more area, the future trend in mathematics, what we're going to have. And this is one more important point I want to put forward, which is the digital twin. So creating a complete real-time virtual model of a physical system, example, a human heart has to be modeled. So for that modeling, so you can't develop a heart, you can model it. And so what you have to do, you have to twin it. Twin అంటే కౌలు అంటారు కదండి, అంటే ఒక సిస్టమ్ కి దానికి సంబంధించిన అదే టైప్ ఆఫ్ సిస్టమ్ మ్యాథమెటిక్స్ దట్ ఈస్ కాల్డ్ యాజ్ ద డిజిటల్ ట్విన్. And that digital twin to create a complete real-time virtual model of a physical system. Every mathematician's target and every mathematician challenges this. So, as we said, a human heart has to be a model. How difficult it is. So, the ultimate analysis and prediction. So, this is a digital twinning. For everything what is existing in the real world, you have to make a twin of it in the mathematics in the form of a model. So that is the upcoming area in case of the converging frontiers and future trends. Okay, now we have arrived at MATLAB at 11:32. Okay, I'll try my best to complete. So what is MATLAB? It's a mathematical laboratory. The core philosophy is MATLAB short form of matrix laboratory is a high performance computing environment designed with matrix-centric philosophy. Matrix-centric philosophy is employed. So its syntax closely mirrors mathematical notations, making it intuitive for mathematicians, scientists, and engineers. So mathematics we have extensively used. I have extensively used. It is a very wonderful tool. It makes your life easy while teaching, and if you want to practice some good aspects, right? So core philosophy is this. Key advantage happens to be what? It excels the rapid prototyping algorithm development by lowering the cognitive barrier between theory, concept, and computational execution. And it is an ID called as the integrated development environment. So MATLAB provides a single cohesive environment that unifies all the aspects of research work. And in one window, you can get all of this. So what it means is integrated. I'll open that. So it has a workflow of command window. It has the editor and debugger. It has a workspace. And four different IDs, integrated development environments, combined together. Major integrated parts are there in MATLAB. So foundation mathematical capabilities, MATLABs provide MATLAB's power is to build three integrated pillars. One is extensive mathematical function library. Second one is the versatile data structures. And third one is the powerful visualization. You know, as I have already shown, that looking at a particular mathematical expression, no one can derive any. If I look at this expression or this expression, if I look at this expression or this expression or this expression, I cannot visualize what is going on because it is a combination of two variables, duty ratios, and D1 greater than D2, D1 less than D2, D1 equal to D2 under three conditions. And what is the range of duty ratio it should be? So that will, based upon the equations, so you are able to do this. And all of these plots are plotted in MATLAB. So you can make a comparison plots. And finally, you can draw some conclusions and so on and so on. So MATLAB offers you this particular flexibility of analyzing things. Extensive mathematical function library is there, a professionally developed and rigorous tested library covering linear algebra, calculus, statistics, and optimization is there. Functions are inbuilt in highly optimized numerical libraries. Glass and milk that I will show. Maximum performance and accuracy. Versatile data structures. Goes beyond standard matrix, includes tables, timetables, categorical arrays for handling complex real-world data. Includes interactive tools. So in MATLAB, we have interactive tools. By varying a particular variable, how the variation of the output can be plotted, data cleaning and processing can be done at a very fast rate. But it demands a minimum of 8 GB of RAM. 8 GB of RAM. And the recent version of 2024. So every year, MATLAB will release 2 versions. So 2025. So I have 2024, 25A I have not got. 2025A means it will be released in January, and 2025B, MATLAB 2025B means it will be released in July. So likewise, every year it releases 2 versions with some or the other advancements. It needs 8 GB RAM, and the software, when expanded, it will be around 30 GB. So your C drive, where you're installing the software, if not C drive, any other drive, it need a minimum of 30 GB of space. Dedicatedly allocated to this particular software is bulk, but it is powerful. If your RAM is less than 8 GB, it will slow down your system. Right. Perfect visualization engine, one of its most acclaimed features is enabling the creation of quality 2D and 3D plots, animations, interactive figures, and script-based approaches ensure reliability of graphs. So this is how MATLAB window looks like. So this we call it as, is it visible?
Yes, sir. Yes, sir.
A MATLAB window, I think.
Yes, sir.
Yes.
Okay. So this is the MATLAB window IDE, interactive, integrated graphic design development environment, whatever is there. So this is the current folder, and this is the workspace, and this we call it as the editor. And this is the comment. So if I want to say hi, so what I'll do, I have to write it as hi. So this is how the command window, every command you can execute. So if I'm writing some command, if I have some code like this, so this code is around, I think I have written it for around 980 lines is the code. So this code, after I write, what I can do is I can execute it stepwise. So run and edit. You can run this at once and get the output. I will run this and show. Or I can run it step by step and I can show. And I can run a particular section of it and I can get the result and so on and so on. So these are all the things what we have. Once it is executed, I will show. So powerful visualization engine can plot 2D and 3D plots and applications across mathematical disciplines. MATLAB native domain is where it dominates the other softwares is the numerical and applied linear algebra. MATLAB's native domain excels in solving linear systems, eigen problems, matrix decompositions, singular value decomposition, whatever is their applications like image compression and so on. So applications of MATLAB extensively can be found in calculus and differential and equations, featuring the suite of robust ordinary differential equation solvers, ODE45, ODE15S, for modeling the dynamical systems, including the solvers PD, EPE, and 1D partial differential equations and so on that I will explain. I don't know how much time I'll get. The third is the statistic and stochastic modeling phenomenon the MATLAB supports. It provides a solid foundation for data analysis, probability distribution, and hypothesis testing. Its random number generation idea for Monte Carlo simulations is very good. Monte Carlo simulation is for worst case simulation. It is very good in that one. And optimizations and operations research, MATLAB is very useful. Includes the foundational solvers of finding maximum minimum functions with and without constraints. So imposing constraints and getting the work done. fmin search, fmin con are the general commands which are generally used in MATLAB to address the optimization and operational research. Core functions at a glance, if you just have a glance. So the command of MATLAB, generally they are very near to the general name what we generally give. So eigenvalues and eigenvectors can be represented as a command EIG. So it is very near to the command or the original name. The command is very near to the original name. So it is very easy. Coding is a little bit easy. So single value decomposition, it is named as SVD. Numerical integration, 1D EQ is integral, so on and so on. So unconstrained optimization, fmin search, fast Fourier transform, FFT, plot XY, plot XYZ, set, and so on. These are some core MATLAB commands what we have. So the researcher's arsenal is the essential toolbox. What research arsenal and multiple research and the weapons ni arsenal. What essential arsenal is essential toolboxes. The symbolic mathematical toolbox, whether it is pure or applied mathematician, has to have symbolic mathematical toolbox, which analyzes the analytic mathematics and symbolic computation. And the key features are exact solvers, solve, desolve, and so on. Formula manipulation, variable precision, arithmetic precision, arithmetic code generation, everything is there. You can generate even the code and you can export the code. Or you have a data can be imported into MATLAB and it can be worked. So I have simulated. So you can see how these graphs will be done after that. So different typical complex analysis can be done by using this particular method. So you can see, you can visualize whatever the expression we have written, that can be visualized and plotted and analyzed, and thereby you can derive conclusions back. So these are different methodologies what we have. I have done some one of my research topic, just trying to plot. So it will try to give you different plots per constraints what you're going to keep. Right. So statistic and machine learning toolbox. The core purpose is data-driven modeling and advanced statistical analysis. Interactive apps are there for statistics and machine learning. So classification, regression learners, advanced algorithms like SPMPC, hypothesis testing, and so on. So optimization toolbox. Three key research areas, arsenals. Mathematicians' arsenals are these three: symbolic mathematics, statistics, and optimization. Solving wide range of optimization problems like LP, and UP, NLP, linear programming, fmin con, problem-based workflow, automatic differentiation, a local maximum, local minimum, global maximum, global minimum, and so on and so on. Constraint and unconstrained optimization, everything can be dealt with MATLAB. So the MATLAB research workflow, I think you people may not get this type of presentation. I don't know whether you get this or not. Because what I'm doing is I'm trying to show the engineering prospect from the eyes of mathematician. That I'm trying to do. So maybe rarely you may get these points, I think. So MATLAB supports the entire research life cycle within the integrated environment. Model and prototyping is a phase one. If you want to do a research with MATLAB, what you're supposed to do? A phase one consisting of modeling and prototyping. Phase two is simulation and refinement. Phase three is visualization and dissemination, dividing the work into different parts. So phase one, modeling and prototype, use symbolic mathematics, use the command window as a scratch pad, scribbling pad or scratch pad for rapid experimentation, and quick build prototypes using high-level built-in functions. And phase two is simulation refinement, import the data from a clean real-world problem. You can take the data of a climate system from the Center for Climate, and you can import the data and you can project how the climate is going to vary, and so on and so on. Accelerate large-scale computation with parallel computing toolbox. So the MATLAB offers you two type of, the task can be divided into two parts. one can execute one half, the second half can be executed by other process. And thereby at the end, both can be combined together. So parallel computing toolbox is there, which makes the life easy and in getting the results at a faster pace. And fit more parameter to data using MATLAB optimization toolbox and identifying performance bottlenecks, the hurdles, the problems, the challenges, and with built-in profiler, so you can identify the performance bottlenecks and you can address them. And visualization and dissemination, you can create reproducibility, publication quality graphics. In your publication, you can improve the graphics of your graph, what you want to show. Live editor, which will give instantaneous results and create interactive model, combines both text and equations with transparent and shareable research. And export the graph to PDF or LaTeX or whatever. So these are some of the useful MATLAB, how it is useful for research and how the workflows goes on in case of MATLAB research is explained on this side. So we have come to the end. So MATLAB is a powerful integrated platform. MATLAB offers highly productive, intuitive environment for mathematical research with a seamless workflow from concept to publication. From concept you're going to have until publication, this MATLAB supports. Okay. Next is the domain-specific strengths. It remains a dominant tool in engineering and applied fields of mathematics due to robust numerical libraries. Engineering is nothing but extensive mathematics, that's all. When I say engineering, people need not get offended. So powerful visualization and specialized toolbox like Simulink. And a golden cage, it has its own limitations. Primary drawback are the proprietary nature of high cost. Is the only problem with that level is the high cost. You have to purchase it, that's all. Best is you can use it without barriers. And nice collaboration, you have good target audience are there, good support is there, a number of specialized areas are there, and so on and so on. So the MATLAB is continuously evolving in catering the requirements of mathematicians. The modern approach, the most effective strategy is often the hybrid one. So rather than being on pure mathematics, you can mix up with engineering students or faculty, or you can work with science people, physics people, biology people, and so on. So mathematicians can work with anything. So that is a flexibility what they have. So being multilingual and leveraging the interoperability between MATLAB and open source tools like Python. You can communicate Python and MATLAB. That provides good results and provide best of both worlds. Right? So this is the last but one slide, and we are going to the last. The final conclusions are the old divisions are going away with more integrated vision of mathematics. Mathematics is not confined only to mathematics. Mathematics is a problem of engineering people, right? So mathematics, when we say we are also mathematicians, engineers are mathematicians, but extensively we are applied mathematicians. Okay? So the future of discovery lies in creative synthesis of abstract theory, practical application, and computational power. The 21st century mathematician is increasingly a polymath, a theorist, a mathematician. In this era, mathematician has to be a theorist, a modeler, a computational scientist, a fluent in language of proof, applications, and so when you say mathematician, you should not confine yourself only to teaching. You have to be a good theorist. You have to be a good modeler, a developer of physical model. A modeler means development of physical model in that sense. And a computational scientist. You have to be a good computational scientist if you want to be a polymathematician. So you should be fluent in the language of proof, how you're going to prove, and how you're going to interact, how you're going to support your methods, and so on. Applications and algorithms. So a mathematician can become a very good computer scientist. Alan Turing is an example of it. Because of him only, all the recent computing systems came into text. So this is my final conclusion. Total of 22 slides, around 2 hours it has taken. Now we will move on to any doubts so far?
Yes, sir. This is Mr. Somashekar.
Yes, sir.
Hello.
Yes, sir.
Sir, I have one small doubt, sir.
Yes.
We are the lecturers or the professors that we have joined to listen your lecture today.
Okay.
Very much appreciate the organizer that they have taken you as a reference and given the beautiful inputs regarding the research work and the field and the basic concepts of MATLAB. But
Thank
the
you, sir.
thing
Thank you,
is,
sir. Yes.
I came to know, thank you very much, sir. But my question is, I came to know that JNTUH is also about to introduce a MATLAB as a laboratory for the first year students
Okay, sir.
from the next year or this year or so. I don't know this year it will happen. It may be happen next year. But how
Okay, sir.
well we can introduce to the first year students regarding this MATLAB? What is the process that we can able to adopt so that student can understand very easily? No doubt that there are some commands that you have shown in the case of your MATLAB respect to eigenvalues, matrix computations, and blah
Singular
blah blah and
value.
so on. Yes, SVD and so on. Even though we can use it for vector calculus also by using
Yes.
some knowledge of MATLAB. But the thing is that students cannot able to understand directly if it is the MATLAB with commands. I hope you are understanding, sir.
Yes, yes, I'm understanding, sir.
Can you please tell us that in what way we can approach to first year students if they introduced by JNTH from next year onwards so that they can able to understand?
Okay, sir. So in that case, I can share with you all some basic examples. I think I have prepared it, but I think that mismatch of size has come. So maybe I'll share these slides with you people.
Yeah, no doubt there are some commands are there. If they type those commands in MATLAB command window and run the program, no doubt they will get the output. The good intelligent student can ask or raise the question like this: Sir, we are anyhow doing the mathematical computation in the class itself. Then why we have to use this command to get the output in a short interval of time? Why unnecessarily MATLAB has been introduced?
Okay. So in that case, sir, you can answer like this. With small equations, it is fine. But a small equation also has a graphical approach. Of course, y is equals to mx plus c is there. So it is an expression for a linear equation or linear graph. So
No, sir. No, as far as you know, in my knowledge is concerned, for every concept of mathematics in BTech level, if you give the command itself, you will get the answer directly, sir.
yes,
Even we can do the MATLAB in any case of the research also. I think you might be knowing also. Then how well the student can understood about this concept?
sir. For that me to explain, I need another 1 or 2 hours. Maybe some other session we can plan. Because we as a lecturers or we as a faculty, we can understand and we can use it in a very good way.
Yeah.
Young mind with a budding ideology. So for them, what happens is adding essence to their life, adding essence to their learning. You can call. So means what? General computational methodology, what we are teaching day-to-day life, they are practicing, getting it a solution is fine. So whether the solution they have got is right or not, how they will check it?
It can
There
be
should be
done.
some.
They can first they can do the mathematical computation manual and they can compare with the result of that command also.
Okay, the time taken for that approach and time taken for
And this
command.
yes, time taken, no doubt. MATLAB is less time it is taking, and that one is more time it is taking. Manual is more time it will take.
Yes. So if I'm trying to plot a variable, just like this one, may not be for students. So if I'm trying to plot the variable which may be shown on the window, so how you're going to interpret this results? You're going to get the output you're going to get. How you're going to represent, how you're going to have an analysis, intuition into this.
Yes, analysis has to
Unless
be done.
otherwise unless otherwise you generate some graph or unless you analyze the data, then only it is possible. So hand-driven sketchpad-based divisions and sketchpad-based approaches to learn technique is confined for a smaller classes, it is fine. But as you excel, but our learning will not be limited to only learning smaller things. But as you try to evolve, you have to address them that. As you try to evolve, now this class is giving you smaller problems. But as you advance, you can have a very big problems which cannot be solved by a normal hand-based calculation. So in that, this class, whatever you're learning now, it becomes a basic for that higher learning. You can address it, sir. That's not a problem. And if at all, if this course is getting introduced, we can have one more session so that we can learn the basics of it. Because 2 hours is not sufficient time to...
Yeah, I can understand what you are saying, sir. Yes, I think everybody will accept my words that I have told just now. Because everybody is working in any college, any BTech college, and they know very well about the JNTH programs. And this time they are changing the syllabus also. It already came in the internet. That's why I asked the question.
Yeah, sure, sir. No problem. It's a good question, to be frank, actually.
Thank you, sir.
Yeah, thank you so much.
Thank you.
Hello, sir.
Sir.
My name is Sudhir Kumar, sir.
Yes.
Can you please suggest one book for MATLAB for referring dynamical systems?
Yeah, sure. Can I send it to... I'll have a soft copy. I'll send to organizers. Manjula ma'am.
Yeah, please send that link in the chat box so that we can refer that.
Yeah, I'll send to her. Maybe she may distribute to all.
Thank you, sir. Thank you.
Okay, sure. Thank you.
Thank you, sir, for the wonderful session, sir.
It's not started, right? Now it is starting. Oh, time is over. Okay. Sorry.
Right.
Sir, I request my colleague, Mrs. Sarla Madam, to deliver the vote of thanks.
Okay, ma'am. Thank you. Thank you all. Thank you once again for the Malla Engineering College for providing me the opportunity to give a lecture on this one. Thank you.
Sir, please share your
Thank all the
PPTs.
participants. Yeah, I'll try my best to share. Because this I may not share to all. This I have taken some time to prepare. I'll share some of it, not all.
Distinguished
I
guests.
thank organizers. Let me finish, ma'am. I thank organizers and all the participants for their patience listening. And I'm so happy to be associated with you all. And I'm feeling privileged to deliver this lecture.
Sir, one minute. Distinguished guests, respected colleagues and dear participants, I T. Sarla, Assistant Professor of Mathematics in the Department of H&S at Malla College of Engineering. As we come to the close of this enlightening faculty development program on MATLAB programming, a primer, it is my privilege to extend a heartfelt vote of thanks to everyone who made this event a success. First and foremost, I would like to express our deepest gratitude to Dr. E. Vazil Kumar for sharing his extensive knowledge and valuable insights with us today. Your presentation was truly inspiring and has provided us with a deep understanding of MATLAB programming. Thank you for your time and for being a part of this program. Thank you, sir. I would also like to thank our principal, sir, Dr. M. Ashok Garu, and HOD Madam, Dr. Sneha Joshi ma'am, for their continued support and encouragement. Your guidance has been instrumental in organizing this event and fostering an environment of academic excellence. A special thanks to the organizing committee and all the staff members whose hard work and dedication have made this program possible. Your efforts behind the scenes have ensured that everything ran smoothly. I'm also grateful to all the participants for your active engagement and enthusiasm throughout the session. Your presence and participation have greatly enriched the discussions and made this event truly interactive and beneficial. Lastly, I thank each and every one of you for attending and contributing to the success of this faculty development program. Let us take the knowledge and insights gained today and apply them in our respective fields to derive innovation and excellence. Thank you once again, and I wish you all the best in your future endeavors. Thank you, sir. Thank you, sir.
Thank you so much.
Long time విన్నాం కదా మనం.
Please fill the feedback form that is available in chat box.
Madam, link is not opening, madam.
Okay, sir.
Madam,
Yes, ma'am, it's not opening.
please provide the link in WhatsApp group also, madam.
Okay, sir.
Madam, feedback link is not opening, madam.
We will provide, sir. We will provide.
Sir.
1 second, sir.
Ma'am, can I sign off?
Okay, sir. Okay, sir.
Yeah, thank you.
Thank you, sir. Thank you.
Sir, can you please send us the comments, sir?
రాజేష్ ఇవ్వండి జిరాక్స్ కూడా ఉంటుంది.
పెట్టాము చాట్ బాక్స్ ఉంటుంది చూడు, అది ఓపెన్ కావట్లేదు అన్నారు, ఒకసారి చెక్ చేస్తున్నా. అది మెయిల్ ఫిల్ అయింది కదా, అందుకని రావట్లేదు. అదే రావట్లేదు, తెలుసులే. చూస్తున్నా సార్, దాని గురించే కదా. 1 minute సార్, పెడతా వాట్సాప్ గ్రూప్లో. వాట్సాప్ చేస్తా, ఆల్రెడీ ఓపెన్ అయింది. అదే మేము ఆల్రెడీ ఓపెన్ చేసి చెక్ చేసుకున్నాము. అది నాది మెయిల్ మొత్తం ఫుల్ అయిపోయింది, అందువల్ల ఓపెన్ కావట్లేదు. వరుసగా చూస్తున్నాను, నాకు చేస్తున్నా. కొన్ని డిలీట్ చేస్తున్నాను అన్నెసరీ. నేను అదే పనిలో మనం చేసింది అది మెయిల్ మొత్తం ఫుల్ అయింది, అందువల్ల నేను ఆల్రెడీ చెక్ చేసుకున్నాను. డిలీట్ చేస్తే కొంత ఇది వస్తుంది, రావట్లేదని చూస్తున్నాను. గ్రూప్లో పెడదాం, వాట్సాప్ వస్తుందా? ఇది చూడండి, చెక్ చేయండి. ఇప్పుడు వస్తుందా? అది మొత్తం ఇన్బాక్స్ ఫుల్ అయి ఉంది, అందువల్ల రావట్లేదు. ఇప్పుడు చెక్ చేసుకోండి, డిలీట్ చేస్తాను. యూట్యూబ్లో పెట్టలేదు. మనది మొత్తం మెయిల్ ఫుల్ వల్ల రావట్లేదు, అందుకని పార్టీ అన్ని.
Hello, madam. Please provide the link in WhatsApp group also, madam. Link is not opened.
వాట్సాప్లో మేడం ఒకసారి అడిగి చూస్తాను, మేడం పెడుతుంటే ఇప్పుడు వర్క్ అవుతుంది. మేడం చెప్పండి, రైట్ నౌ వర్కింగ్ అని. ఓరల్ ఫీడ్బ్యాక్ అంటే అదే మెసేజ్ ఇంకోటి వాట్సాప్ లో మెసేజ్ ఫార్వర్డ్ చేస్తాను, కొన్ని ఇంకా మంది రాదేమో, ఒకసారి చూస్తాను. యాక్చువల్లీ 10 to 12 అని చూపించాను సార్. ఇప్పుడు లైన్ వర్కింగ్ ఒకసారి ఓరల్ అడుగుతాం సార్.
సార్ ఓరల్ ఫీడ్బ్యాక్ వినాలనుకుంటున్నారా? వాడు ఓరల్ అడగాలి కదా, ఒకసారి నన్ను కూడా యాడ్ చేసి అడగమంటున్నారు. పార్టిసిపెంట్స్ అందరినీ మీ ఫీడ్బ్యాక్ ఏంటి అని అడగమంటారు సార్.
ఓకే
ఉన్నంత వరకు చెప్తారు సార్. ఎవరైతే ఉన్నంత వరకు చెప్తారు. మీరు చెప్పండి ఒకసారి అడగండి.
నేను ఇక్కడ వర్కౌట్ లా చూస్తున్నాను మేడం. మెయిన్ వర్కౌట్ లా కొన్ని డిలీట్ చేస్తే వర్క్ అవుతుంది.
Hello everybody. Please share your feedback, valuable feedback about the FTP. Dear participants, please share your feedback about the FTP.
యాడ్ చేయాలి. ఆల్రెడీ ఉంటారా ఇంట్లో రావాలి. యాడ్ చేయాలి. వర్కౌట్ 79 మెంబర్స్. ఇప్పుడు ఒక మెసేజ్ పెట్టండి. ఒక మెసేజ్ ఏంటంటే రైట్ నౌ
So, dear participants, please share your valuable feedback about the FDP. Oral feedback చెప్పండి. మీ డౌట్స్, మీ క్లారిఫికేషన్స్ ఏమైనా ఉంటే. Dear participants, please share your oral feedback about the FDP, please.
నేను చాట్ బాక్స్ లో పెట్టిదా. నేను చెక్ చేసా వస్తుంది.
ఇక్కడ ఉంది 3 points. Feedback form coming. Please share your oral feedback also about the FDP. Dear participants. మంజునా మేడం.
వస్తుంది అది నేనే పెట్టిందా. పైన రత్నాక వస్తుంది కానీ నేను పెట్టింది అది. అంటే సార్ ఏం జరిగిందంటే మెయిల్ మొత్తం ఫుల్ అయిపోయింది. కొన్ని డిలీట్ చేస్తున్నాను అందువల్ల. అది తెలియదు మరి నేనే అది పెట్టింది నేనే ఉంది. ఎందుకంటే నా మెయిల్ మొత్తం ఫుల్ అయింది. డిస్క్రిప్షన్ ఫామ్ కూడా ఓపెన్ కాదు. అందుకోసం మెయిల్ మొత్తం క్రియేట్ చేసిన నా మెయిల్ కదా, అందువల్ల రాదు.
గుడ్ మార్నింగ్ మేడం.
మేడం ఉన్నారా? హలో
హలో
మేడం.
హలో
హలో మేడం, దిస్ ఈస్ సోమశేఖర్ ఫ్రమ్ ఎంఆర్ సెట్ మేడం. మేడం సార్ ఎంఆర్ సెట్ నుంచి మాట్లాడుతున్నా. ఎంఆర్ సెట్ నుంచి.
చెప్పండి సార్.
చెప్పండి సార్.
ఇది కమాండ్స్ సార్ ఏమైనా పంపిస్తారేమో అడుగుతారా మేడం? కమాండ్స్ ఆఫ్ ఈచ్ టాపిక్ ఇన్ టాపిక్స్ ఆఫ్ మ్యాథమెటిక్స్ ఫస్ట్ ఇయర్ నుంచి థర్డ్ ఇయర్ వరకు టాపిక్స్ ఉన్నాయి కదా. ఫర్ ఎగ్జాంపుల్ ఫాల్స్ పొజిషన్ మెథడ్, కమాండ్ ఏది ఇస్తే అది అవుట్పుట్ వస్తుంది, టైప్ చేస్తారు కదా, టైప్ చేయాలి కదా. MATLAB లో.
మెటీరియల్ ఈవినింగ్ యాడ్ చేస్తున్నారండి సార్, గ్రూప్ లో షేర్ చేస్తాం.
ఓకే, కమాండ్స్ కూడా ఇస్తే బాగుంటది మేడం.
ఓకే సార్.
అంటే కొత్తగా వస్తుంది కదా, అందరికి తెలియాలి కదా. సరే సరే మేడం, సరే మేడం.
మంజు పెట్టింది ఓపెన్
మళ్ళీ పెడతాను చాట్ బాక్స్. చాట్ బాక్స్ పెట్టావా? ఓకే, ఒక మెసేజ్ పెట్టండి గ్రూప్ లో, లింక్ వర్క్ అవుతుందని. నేను చాలా ఉన్నాయన్నీ రీడ్ చేస్తున్నాను. వాళ్ళకి ఇది మెయిల్ మొత్తం చాలా ఎక్కువ ఉన్నాయి. ప్రాబ్లం లేకుండా రిజిస్ట్రేషన్ ఫామ్స్ కూడా మా అందరికి ఇంకా ఓపెన్ అవ్వదు. ఎందుకంటే ఎవరు క్రియేట్ చేశారో వాళ్ళ వరకే వస్తాయి. ఫుల్ అయిపోయింది. అందుకని రిజిస్ట్రేషన్ ఫామ్స్ కూడా
వచ్చాయి రా 3 యూనిట్స్ వరకు వచ్చాయి. 4 యూనిట్స్ వచ్చాయి. ఒక 14 అగ్రి చూసావా, మేము పెట్టినా కూడా వాళ్ళు ఇష్టంగా ఇస్తారు. ఇలాగే ఇవ్వమని చెప్తూ చెందాలని చూసి నాకు పంపించు.
అది చాట్ బాక్స్ లో అందులో పెట్టుకోవాలన్నమాట. కొన్నిసార్లు చాట్ బాక్స్ లో ఉంది కదా, అది తీసుకోవాలి. మెసేజ్ చాట్ బాక్స్ ఓపెన్ మెసేజ్ పెడితే చాలు. ఓకే కదా ఇంకా మళ్ళీ వస్తుంది వర్క్ ఇన్స్ట్రక్షన్
Ma'am, have you taken it?
ఎవరు లేదు, ఇప్పుడు దీంట్లో నా మళ్ళీ వర్క్ చేయదు, కొన్ని డిలీట్ చేస్తున్నాను. మీరు ఏమైనా ఉంటే అడగండి. వేస్టేజ్ మళ్ళీ
హలో డియర్ పార్టిసిపెంట్, ఇంకా ఏమైనా కావాలా మీకు? ఎనీథింగ్ ప్లీజ్ గివ్ యువర్ ఓరల్ ఫీడ్బ్యాక్ ఆల్సో. రిమెంబర్ షేర్ మెసేజెస్. Anything you want about MATLAB, please ask me. Sir, join, please tell what you want.
ఓకే కదా. 30 మెంబర్స్ ఉన్నారు. వన్ 10 మెంబర్స్
ఫిల్ చేశారా సార్? సపోజ్ ఇంకెవరైనా ఫిల్ చేయాలంటే పర్సనల్గా పంపించేద్దామా మీకు అంటున్నాను.
మేడం అడిగి పంపిస్తాను. ఎందుకంటే పర్సనల్గా అయితే
పర్సనల్గా పంపించేద్దాం అంటున్నాను. వాట్సాప్ గ్రూప్లో పంపలే. ఇప్పుడు మేడం నేను ఇలా క్లాస్ ఇంటిగ్రేషన్ ఉంటాను, నాకు ఇవ్వండి అని పంపించేస్తాను నేను. ఓకేనా సార్? అది తెలియదు చేసామని
ఇది చేస్తున్నారు, పెరుగుతున్నాయి 112. ఇది లింక్ ఎందుకు
అంటే
వర్క్ అవ్వాలంటే
లాస్ట్ టైం చాలా మంది సఫర్ అయ్యారు సార్. లాస్ట్ టైం ఏంటంటే చాలా మంది ఇన్విలేషన్స్ క్లాసెస్ ఉన్నాయి, ఫ్యాకల్టీ మ్యాథ్స్ ఫ్యాకల్టీ అందరూ క్లాసెస్ ఉన్నాయి. కాన్సెప్ట్లో క్లోజ్ చేసేసాం వాట్సాప్.
మనం ఇట్లానే చెప్తే ఒకసారి పెట్టుకుంటాను సరే పంపించండి.
అది ఎంతసేపు తీసుకున్నారు? క్లోజ్ చేయరు కదా.
క్లోజ్ చూద్దాం.
క్లోజ్ చేయక ఇది కాదు గూగుల్ ఫామ్ది లింక్ క్లోజ్ చేయకండి అంటున్నాను.
గూగుల్ ఫామ్ లింక్
అది కూడా లేదు, మనం ఆఫ్ చేసుకోవచ్చు. 2 hours ఆఫ్ చేసుకోవచ్చు. చేయకండి.
అది నాకు తెలియదు. అది ఎట్లా ఉంచుదాం తర్వాత
రేపు అలా కావాలంటే క్లోజ్ చేసుకోండి సార్. 150 అయిపోయిందా? 115.
ఇది ఎందుకు అంటే ఇది మొత్తం ఫుల్ అవుతుంది. అందుకోసం మేము ఆల్రెడీ చెక్ చేసుకున్నాం. చెక్ చేసాము.
అందుకే నేను ఏమన్నా అంటే మీ మెయిల్ ఎక్కువ ఉంటుంది కాబట్టి ఆ మెయిల్లో ఫీడ్బ్యాక్ చేయించాల్సింది.
దాన్ని వింటుందా? పెట్టుకుంటే ఇది సిస్టమ్
ఇది సార్ది, శ్రీకాంత్ సార్ది కదా సార్ ఈ ల్యాప్టాప్. ఆఫ్ క్లోజ్ చేసేస్తున్నా నేను. మీరే క్లోజ్ ఆయన పిలుస్తానైతే నాగేశ్వర్ సార్ని. హలో, ఎక్కడున్నారు? ఎక్కడున్నారు సార్? క్లాస్లో ఉన్నారా? ఓకే ఓకే, సరే సార్. క్లాస్ అయ్యాక ఇప్పుడు అయిపోద్దా క్లాసు? అవునా, అదే పైన అక్కడికి వెళ్దాం అంటున్నారు హెచ్ఓడి మేడం దగ్గరికి, అందుకని కాల్ చేశాను. అదే అయిపోయింది కదా ఎఫ్టీపీ, అందుకని. ఇప్పుడు వెళ్దాం అంటున్నారు సార్, శంకర్ సారు. ఎలాగో 12:30 అవుతుంది, అక్కడికి వెళ్ళే లోపల 12:35 అవుతుంది. మీరు వచ్చేసాను. ఓకే సార్. ఓకే సార్. మంజు, ఇందాక ఏం జరిగిందో ఎవరో మాట్లాడుతున్నారని చెప్పి సార్ నేను ఉన్నట్టు మనకి చెప్పాను. వర్జులు ఆయన్నే రిమూవ్ చేయబోయారు. చేస్తుండాల్సిన పని మీటింగ్ ప్రోగ్రామ్ ఎప్పుడు అయిపోయేది. సార్ ఇది మీ ల్యాప్టాప్ ఆఫ్ చేసి మీరు తెస్తారా సార్? పడింది ప్లగ్. మంజు లగేజ్ ముందు పట్టుకో. బ్యాగ్ తీసుకెళ్తారు, అది
మేడం. ఒకసారి హెచ్ఓడి మేడం మీకోదాము. హెచ్ఓడి మేడం ఉన్నారా?
స్టాప్ చేస్తున్నా.